chapter is about factoring. I don't know if you took time to look through your algebraic goal sheet yesterday for this chapter, and remind me, Haley, and we can give them to you during homework time. This, and I feel like oftentimes I say this almost about every skill there is, because algebra is such an important class to get a really good base in, and I feel like I say this about almost every skill. But I honestly have had college students come back to me and say, I wish I would have taken you more seriously when we did that factoring stuff. And I kept saying to them, you need to learn how to factor. You're going to use it and use it and use it. And so you need to know how to do it. And so, needless to say, some of them are coming back and saying, can I come up and get some help with factoring because I can't remember how to do it, or I didn't take you seriously enough to learn it. So that's what we're going to be doing throughout this chapter, and we start with our learning goal today. I can factor polynomials using the greatest common factor. So that's our first method of factoring. And so we're going to, based off of what you did when you did your own 7.1 note-taking, you should now know how to do factoring of a term. You should be able to get the prime factorization of it. That's something that you should have done in lesson 7.1 yesterday. So, just as 6 can be factored to 6 times 1, or 3 times 2 times 1, so can some other polynomials be factored. So 6 can be renamed as 6 times 1. It can also be renamed as 3 times 2 times 1. Or we could just rename it as 3 times 2, for that matter. So when we are going to be factoring our polynomials, they're not all going to be constants like that. I wish they were, because it would be maybe a little bit easier. Steps to factoring polynomials by the GCF. GCF stands for greatest common factor. So factor each term and find the GCF of the terms. So factor each term. So you're going to take each term and find its prime factorization, basically. And then you're going to find the GCF of the terms combined. You're going to say, okay, looking at you and maybe even looking at a third one, depends on how many there are in the polynomial, you're going to decide what is the GCF of each out of all of those. Then in step B, you're going to divide each term by that GCF. So when we're factoring, we're really dividing out something that they all have in common. And then this is the really important part. Sometimes we tend to forget about that GCF that we divided out. So I want you to underline this. Write the GCF as a factor. That's going to be your first factor, we'll call it. It has to be one of your factors. And the resulting terms after dividing are the other factor. Okay, so this is really, really important. You don't want to forget that, just because you found that GCF and divided every term by it, it's no longer existent. It is one of your factors. Just like if you take 6 and divide it by 3, you don't say that factored is 2. You say that factored it is 3 times 2. So what you divided out becomes a factor, and the result becomes a factor. Okay? So let's practice in number 1 here. We have 9b cubed plus 5b. Here's how we're going to show work, and I think this is kind of how they did it in lesson 7.1. We're going to write each of those terms. Oopsie, I didn't mean to go down to B here. I meant to go to the next line. We're going to give each of those terms their own line here in step A. We're going to factor each of those terms out. We're going to say, okay, what is the prime factorization of this particular term? So what would be the prime factorization for 9? Come on, you did lesson 7.1. That's the reason I had you do it. What's the 3 times 3? What does b cubed mean? B times B times B. Okay, there's 9b cubed, written out, factored. Now let's do 5b. Is 5 a prime number? Yeah, so if it's prime, it really means then its only factors are itself and 1. So we're just going to write that as 5, because it isn't going to get anywhere necessarily to say times 1. And B just means B, right? Okay, now we're going to look for what are the things they have in common. Do they have anything in common? Just one B, yeah. So let's just circle a factor of B in both of them. And we will say the GCF is B. The GCF is B. So basically, you know what I could do right now? I could move down to step C where I'm going to write the factored name for this so that I don't forget about it. And I can say right here, one of the factors is going to be B. In the factored name, one of the factors is going to be B. And we're going to find out what the other factor is going to be here in a bit. So the next thing that we need to do, it says in step B, it says we need to divide each term by that GCF. So we're going to rewrite our addition problem. I think I'll use another color here. We're going to rewrite our addition problem that we had. And each of those terms is going to get divided by that B. Each of those terms is going to get divided by that B. Now we'll see how good we are at that dividing thing. Anybody know what 9b cubed divided by B is? Benton?
9b squared.
9b squared. How'd you get that?
One of the b's cancels out with the other b.
Yeah. So basically, you know what, let's just rewrite this again so that we don't, can't see what we started with. Let's do this. This is our work, okay? Benton said this b down here cancels out with one of these b's up here. So now there's not 3 factors of b's upstairs, there's 2. And that b that was downstairs is no longer, it's been divided out. And then, how about 5b divided by b? What will that be?
5.
That will be 5 because, why? The b's cancel out. So we can say now then that we have 9b squared plus 5. 9b squared plus 5. So there's our other factor right down here. This is really our final answer right there. So we have this one that we got in step B. We have that one we got in step A. Those two multiplied times each other should really get us back to 9b cubed plus 5b. So let's just do some distributive property in our head. Do you think b times that 9b squared would be 9b cubed? Yeah. Would that b then also taken times the 5 be 5b? Yeah. So this is another name for 9b cubed plus 5b. Why is it going to be important that you learn how to factor? Because you're going to start solving equations that are just like this simple. 3x plus 2 equals negative 7. You're going to have to solve equations that have maybe 3x squared plus 2x minus 1 equals 4. How are you going to solve that? Factoring is going to help you. Okay? Anybody have any questions on that one before we try the next one? Okay. Let's rename this one first of all. Take this one and rename it as add the opposite. Okay, now, in step A, remember we take each of the terms and we factor them out individually. So we take each of those terms and factor them out individually. Prime factorization of 15. What is it? 3 times 5. Okay. A squared means A times A. Negative 5A. Okay, but you know what we can do since it's a negative 5, we can factor out a negative 1 and make it positive, because you know why I want to make it positive? Because I have a positive 5 in the other one, so I'm thinking, you know what, it would sure be handy to have a positive 5 in this one, so they had something in common, and then times A. when you have a negative number, that really means you can factor out a negative 1. If you have a negative variable, that really means you can factor out a negative 1. And now we'll see, what do they have in common? Well, they do have that positive 5 in common. We could not say they were in common if one was positive and the other one was negative. You have to make sure they're the same sign also. And they have an A in common. So we are going to say that the GCF of these two terms is what? What do they each have? They each have a 5A. So there's one of our factors right there. So right now we could really go down here and say, you know what? One of our factors is 5A. Next thing we will do is we will go and divide. We'll write down our problem the way we had it. We changed it to plus and negative 5A. We will divide both terms by that GCF of 5A. So again, especially in your notes, it's always nice when you're going to go back and use them later for a quiz to have good, clear notes to follow. Let's show our work. Let's just write it again and show our work in the next one. Where we're going to do our crossing out and all that kind of stuff. So, what do you think we can do with that first term? 15A squared divided by 5A. Is there a number part that goes into both of them? What? Does the 5 go into itself once and into 15 3 times? 2 factors of A upstairs, 1 factor downstairs. What can we do? Cancel out the A downstairs and make this a 1 upstairs. We took one of those and divided out upstairs. Okay, how about the next one? Negative 5A divided by 5. This can go in here a negative 1 time. And can those A's cancel each other out? Mm-hmm. So what do we have? Now what can we say this becomes? We have, what's this? What does this term end up as? 3 times A to the first, which is 3A. Plus. What does this term become? Which is negative 1, right? So we are going to say this is our other factor. We're going to bring it down here with our 5A, and we're going to clean it up and say that 3A minus 1 would be the other factor. So 5A times 3A minus 1 would actually give us, would be the factor name. I want you to multiply it out though. I want you to check. I want you to do a check here. I want you to take this because you're good at multiplying now. I want you to multiply that out. I don't care which method you use. Whatever you got to do to multiply that out. What is the result? Does it take us back to where we started? Okay, it's the same polynomial. This is important that you grasp this. We did not just invent something new here. We have taken the polynomial 15A squared minus 5A and just given it a different name. Just like we can rename 6 as 3 times 2, we can rename 15A squared minus 5A as 5A times 3A minus 1. So we've just renamed it. That's all we've done. That's called its factor name. So any questions on this one? Okay, let's go try it. Oh, a trinomial. Okay, well, in a trinomial, that means you have to find the GCF of how many terms? 3. Okay, so we're going to write down that we have 12h to the 4th. We have 8h squared, and this really can be rewritten as add the opposite. We would end up with plus a negative 6h. Nothing says you can't just keep it as subtraction and then make sure that you remember that it's a subtraction sign in between those two terms. But sometimes we forget that, so it's better maybe just to make it the negative. Okay? So remember what we're doing here, we're factoring each term. What's the prime factorization for 12? 3 and 4? You guys agree with her?
2 and 6.
I propose it's more than just two factors. 2 times 2 times 3. 2 times 2 is 4. And 2, those are prime numbers. Remember, prime factorization means every factor is a prime number. So 2 times 2, we had to rename that 4 as 2 times 2, and then times 3. And then we have h to the 4th means, oh, you got 4 factors of h. We will not forever have to write all this out. We're going to be able to do this. We're going to be able to pick out a GCF without having to write all this out at some point. But we're not there yet, I don't think. What's the prime factorization for 8? 2 times 2 times 2.
Why do we have to do 3 numbers?
Because we want prime factorization.
I don't know, why can't you just do 8?
Because then we won't be able to see which factors they have in common.
Oh.
Okay. How about negative 6h? Well, let's take care of the negative with a negative 1 first of all. 2 times 3. And times 1 factor of h. Now, we're ready to say, okay, what do they all have in common? What do they have the same? They have a 2 in common, okay. They have an h in common. Anything else? No. They gotta all have it. All 3 of them do. So the GCF of this one is, what's the GCF? 2h, the thing they have in common. So there's one of our factors. It is what we're going to divide by. So now in step B, we take each of those. Let's just write the problem out first of all. 8h squared plus negative 6h. Each of those will get divided by that GCF. Apparently I wanted us to have enough room to make sure that we could show this well, so we're going to write it again, and this is where we're going to do our work. Okay, 12 divided by 2 is 6. H to the 4th divided by h is h to the 3rd. Hey, will you just stop for a moment with me and recognize something? If you go back up here, you look up here to the factors that are not circled. If you multiply those back out, the ones that are not in the circled part, if you multiply those back out, what would you have? 6h cubed. 2 times 3 is 6. H times h times h. Plus 2 goes into itself once, into 8 how many times? 4. This h cancels with one of those h's. What do we have? 4h. It's a club. 2 times 2 times h. Oh, that's 4h, isn't it? Plus 2 goes into itself once. Goes into negative 6 how many times? 3 times? Negative 3 times. And the h's cancel each other out. So we have plus negative 3. Oh, look at there. Negative 1 times 3 is negative 3. There's our second factor. Now we are ready to write the factor name for this, our 2h, which will get forgotten. It will get forgotten. I know you'll do it. Just try not to. It's part of the factor name because whatever we have here should multiply back out to what we started with. If I'm going to do the multiplication again now, it better multiply back to that polynomial 12h to the fourth plus 8h squared minus 6h. So this is our final answer here. We won't take the time to multiply it out. We're going to leave it happening, right? Okay. We're going to do one more because this is going to be useful. Just trust me on this. When the leading coefficient is negative, divide out a negative 1 first. Okay? So we're going to first just rename it by dividing out a negative 1 because the leading coefficient for this one is negative 5. When the polynomial is in standard form, the multiplier out front of the first term is the leading coefficient. The leading coefficient is negative 5. So what we're going to do, first of all, is we are going to take each of these terms and we're going to divide them by negative 1 and we're going to rename this as negative 1. It's a factor now. It got divided out. And this is going to become, well, when you divide or multiply by a negative 1, they change to their opposites, right? So from negative 5g cubed to positive 5g cubed. From positive 15g squared to negative 15g squared. And you're like, well, you just traded things off. You just made the other one negative now. Just trust me. When the leading term is positive, it just goes a lot better. Okay, now we are going to do our step A, which says, okay, first of all, this negative 1, it's just gonna it's gonna become part of this process eventually, but just narrow it down for right now. We're gonna kind of let it just hang there. And we're going to take our 5g cubed. Oh, I guess I don't really need my parentheses anymore right now. Sorry about that. Remember, this is, and we're in step A, this is where we take each of our terms and we factor them out with their prime factorization. So go ahead, factor 5g cubed and factor negative 15g squared to their prime factorization. What do you think GCF is? So they have a G, a 5 in common. They have a G in common. Oh, but they have another G in common. Oh, there we go. Sometimes you might miss that, you know. So the GCF is 5g to the second power. It doesn't have to be to the first power of the variable on the GCF. And now we will move on to step B, where in step B, we are going to take each of these. So we have our 5g cubed plus our negative 15g squared. And we're going to divide each of them by our GCF of 5g squared. But of course, you know, we want to be able to tell what we were really doing here, so we're going to do a separate work one. Go ahead. Get those divided. do you get? G. So the only thing left, G to the first power in this one, and it's upstairs. A negative 3 up here. So G plus a negative 3 is what happened after we divided. So, by the way, we got 1, 2, 3 factors right now, don't we? We factored out that negative 1 in the beginning. We arrowed it down so hopefully we wouldn't forget it. We got that 5G squared as our GCF. This is the result after we divided. We now can go to step C and say, you know what, I got a negative 1 times a 5G squared times a G plus a negative 3. But of course, they're not going to show it in the answer bank like that. They're going to clean that up. How do you think they might clean this one up? Yep, take that negative 1 times that 5G squared. You know that thing we did in the beginning, we kind of undid it, and now we're taking it back, and you know, it's like, are you kidding me? Really? Well, yeah. No, I mean, I'm not kidding you. G plus negative 3, how are we going to clean that up? What? I'm asking you that hard of a question. G minus 3. There's our final answer. Whew. And the final answer is negative 5G squared times the binomial G minus 3. Okay, this is huge. We have to take this seriously. Anybody have any questions at the moment before you dive into this homework? Okay, don't shortcut it too much yet. I'm gonna let you start shortcutting your work, but you're not ready. Trust me, you're not ready. Just believe me.